Question. Have you ever lived something magical? The kind of magic you can feel, for real. Now imagine the kind of magic I have in mind. A city that helps you walk safely home at night. That's
Magic.
yes! Or cars that drive themselves. Look at Daphne here.
I can finally go wherever I want to again. It's
Magic! Say hi to the grandkids, Daphne.
Oh, I'm not going to see the grandkids.
Have a good time. Now check out Tom. Saving water, protecting his crops. Come on, Tom, say the word.
Useful.
Tom.
Magic.
Yes! And here's another question. What do you do when you have all this magic? Shall we make it exclusive to the happy few or inclusive to everyone? Should we let it be a threat to our jobs or use it to turn all of us into magicians? Whoa! Whoa!
Woo!
What do you think about that, Lauren?
Magic.
I thought so.
Dr. Erica could... Wow, that's really cool. I mean, magic.
أقدر أتكلم مع سائق الباص وأعلم أطفالي في المدرسة وكل حد في العالم.
Yeah, you go, Yana!
روعة.
Live magic. Magic is this thing talking to that thing that talks to whatever this is and tells the other thing what to do with this thing that speaks to her. Friendlier cities, mobility for everyone, small business efficiency, complex tasks made simple, real-time medical care, a more inclusive society, it's all...
Technology.
Well, yes, I was getting there. So real that it can't be magic. So magic that it's more than just technology. With 5G, we will make magic happen, and everyone can be part of it.
We have seen now a couple of introductions on 5G. We heard from Ivan that 5G is one of the topics which drives the world, will drive the world. And I would like to give you the idea of why 5G is pushing autonomous driving and what do we have to do from today on to reach this goal. So basically, we have seen some magic moments, some wow moments, and autonomous driving is just one of them. And I will concentrate now on this and to tell you what exactly is Telecom and T-Systems are doing especially, but this is true for all of us in the industry. This is true for the automotive manufacturers, for the suppliers, for the IT companies. So this ecosystem is changing a lot, and when we talk here about, say, autonomous driving or some of the other magic moments, they are coming together. We talked and heard about the living room on wheels, which is also a good example. So when we look at the automotive topics, and especially talking about what is the impact of cellular technology, telecommunication on automotive topics, then you will see a lot of interconnectivity in the future. So the cars will talk to each other. The car will talk to whatever backend to ensure that data are flowing between cars, between the infrastructure. Going back to the automotive manufacturer, we talked data monetization earlier today. So this is a kind of an interconnected environment which is growing, which is just starting, and we as Telecom, as T-Systems are from our heritage, of course, in the middle of connectivity, but we're also doing this for a couple of years already from the connected car perspective. And this goes beyond pure cars. When we're looking into autonomous driving, there are also topics like precise positioning in POP. So autonomous means you need to exactly know where you are, within the lanes, outside the lanes. You need to exactly know where the other participants are, not even cars, also bicycles, pedestrians, all this, the topics, all the participants on traffic around you. This is an important input, and this where cellular technology and even 5G can help you. One remark here, it always sounds like 5G is the key enabler for autonomous driving, it's the key enabler for connected cars. There's a lot of scenarios which work today already, with 4G, with LTE, with all the existing technologies. There's no need to wait for the high bandwidth, the low latency. It enables, it helps, and we talked earlier about level 5 autonomous driving. Then we have to have this technology of 5G. But still today, there's a good amount of use cases in our industry which can be enabled using 4G and LTE. So let's have a look of what we do today. And this should give you an insight of where existing technology already enables functions, and it's not an outlook, it's not a future, it's exactly today. And we as these systems build these kind of stuff and operate these kind of environments for a couple of OEM and manufacturers worldwide. And this is where we say collect the different inputs from the business perspective and from the technical perspective. So I'm trying to give you some trends we are seeing. It's not a trend like Frost & Sullivan gives from the long-term analytics perspective, but more on what is happening today. And one key trend is time to market pressure. So more and more features needs to come into cars. So no one is going to buy a new car because of the horsepower. Okay, some of you still exist in the market on this, but connected car features in this area, this adding features over time is an increasing demand and push in that. So and this requires a change in the way we develop software. We put software into the car. There is this notion of the software-driven vehicle and the software-engineered vehicle. And in the end, it's about agile development, about DevOps in a larger scale, not just having a team building up something, but having a couple of teams using in agile enterprise environments in order to build this. So one example here. So for one particular environment, for an OEM, we have over 8,000 changes over the year. If you can imagine what is the change rate per day, per hour in an environment, in a productive environment, this tells you what kind of agility we need in the future. And this is just the beginning. So this is continually increasing, and this changes the way we work. And this comes together with the new feature demand. And just to give you some ideas of what we're talking here, there's this car to X interaction. And you have seen this in the earlier picture. The cars communicating to each other. In the future, they will communicate directly. Today, they still communicate over the back end. So talk to the back end and then distribute the data again to all the cars around. And this feature today gives you information about hazardous situation, traffic jams in front of you, advise you to reroute as needed. And this is, again, just the beginning. And we talk car to car today, but it's saying car to X, which means we also talk about car to infrastructure, which is the first step into the enablement of your environment sensoring with the car for the autonomous driving. I will come to this a bit later because that's one of the key drivers in enabling L4, L5 autonomous driving. Another major trend is we call it together is better ecosystems. We heard already today. There's no longer a single company who can fulfill this demand of the changing industry. So BMW and Daimler are doing Share Now. The tier one suppliers are working closely with the OEMs to develop software, to develop components, to develop sensors, radar, lidars, whatever. And this ecosystem consists of, say, established players, new players, startup, completely different type of industries. And that's what we also see from Deutsche Telekom. This is not just continued business from, we sell some connectivity, we sell a SIM card, we sell some IT development stuff, and the automotive manufacturer will somehow integrate. Now the integration starts much earlier, and someone needs to manage the ecosystem, needs to onboard and offboard partners in order to ensure that they're really working together on the same target. And this is beyond any technology. It's really about the cooperation, about the interaction. And this also is true when you think about the complexity of the future. When we today develop new features that we develop for a particular model, for a particular head unit, for a particular brand. But the more and more we develop over time, the more complexity we do have. And you can imagine if you build an app today, you build an app for an Android, for an iOS, but you still have to test against different models in the market from Samsung, from Apple, from Huawei, from all these mobile device manufacturers, and the same level of complexity is generated if you combine the end user device with the different kind of portals, with the different head units in the car, with the different ECUs in the car. So this matrix of complexity creates an enormous amount of testing, so for quality assurance, make sure it works, but also make sure it works securely. So do not leave a hole somewhere to break into. So this end-to-end security and the complexity around this creates increasing demand for the awareness of security, for the awareness of multi-device integration, multi-brand integration. When we talk about, say, the volumes of data generated out of this, we currently talk about petabytes of data just for logging information. And in the long term, it is not just the logging and the monitoring, which might be 60–70% of a complete environment to run on. In the future, we see also that this amount of data is data transferred between vehicles and backend, vehicles and edge devices, in order to make sure that it all works properly together. Last but not least, we also see conversions of platforms. And platforms, I mean the backends currently to operate connected car environments by OEM. Each OEM has its own backend. Each OEM operates and developed in the past their own components. And there's a certain level of standardization, so where features, how to interact with vehicles, and this is not just cars, any type of moving entities are collecting and sending data, so typical telematic applications. This is more and more commodity. This gets more and more standardized. But the differentiation, so what is my brand differentiation, what is my specific feature for my brand, starts on top of this. So we have platforms, and here the cloud providers play an important role, like Microsoft with Azure, like AWS, to develop more and more vehicle-driven or vehicle-enabling platforms, which gives you the basis, the platform as a service, to develop your own features on top. And we assume that these platforms will merge into or will develop into autonomous driving platforms, because they do have already the standard features like the connectivity to the car, like connectivity to backends, like security, all the end-to-end features needed in order to operate such environments. And in the long run, these platforms merge together, and we also expect them to merge together across OEMs, across market participants, that you have one backend or at least less number of backends compared to today. So basically, that's the today's world, and today we are already talking by manufacturer of a couple of million connected cars worldwide, and the worldwide itself implicitly gives you a level of complexity because global operations requires global distribution of data sources, global distribution of computing power, but also taking care of regional specifics. That can be legal, some data privacy laws, some laws about data not leaving a certain country or handled within a country, but also some feature specifics within a country. So, for instance, for one of the OEMs, we developed applications which specifically navigates in Peking. So the ring roads around Beijing are sort of specific in terms of traffic patterns, and there are specific applications to help navigating in this region. And obviously, this app is valid for Beijing and not for any other city. And this is specific to a region, even to a city in this case, and we expect that this is going to increase further and further, being specific, but in the end still have a global operations for such platforms. So I talked about connected car. Now let's look into the future. What will we do tomorrow and how tomorrow will look like? Let's look at this ICT 2018 Carmen and Croco. These are specific projects targeted to make sure that 5G scenarios in autonomous driving working cross-border. So it's not, it's a challenge basically to ensure that while you are driving cross-border, while you are moving across networks, so even cross-operator from Telecom to Vodafone, from Telecom to Orange, that the handover works properly, that the application context is transferred properly. So it's a combination of what the telecom, the network can do, that's typically 5G components, what the environment can do, that's edge computing, and what the vehicle and the backend can do. And you can imagine that these kind of cross-border projects help to understand how to design the features of the future. And these two projects are also looking into specific use cases. One is called teleoperated driving. So what is going to happen if the driver is not longer able to take over in a level 3, level 4 case? Or what is going to happen if the car itself cannot cope with the situation? So construction work, specific weather situation. And in these cases, we expect a service in the future that teleoperation takes over and drives you safely to the next exit, drives you safely to the right lane in order to ensure that nothing has happened and that the overall security and safety is still maintained. So these are still research projects, but these projects feed back into industry, feed back into university, feed even back into development and innovations in order to drive the next level of application. Say, in the next one, I would like to go into more detail is the DigiNet PS, the second from the top. DigiNet is, in more detail, a test environment in Berlin, where Telekom and T-Systems operates with the Technical University. And you see this little map over there. It connects currently a roughly 4-kilometer track from Brandenburger Tor to Ans-Reuterplatz. And for those of you who know Berlin, who've been there, you know that's a quite crazy street, 2 major roundabouts where all the people on driving lessons go crazy. And this route is basically equipped with external sensors along the street in order to ensure that the car receives the information which are important to drive autonomously. So it's a digitized environment with a good number of sensors with some details. We have vehicles equipped to receive this information and take care that the information about your environment are included in the autonomous driving patterns, so that the car is taking care of what's happened around and decides accordingly. And this can create different driving patterns, so speeding up, decrease of speed, getting in time to the next green light, but also supports safety, so taking care of pedestrians, taking care of a person who's just parking out without having a look. All this information are part of the sensoric on the street, and with these 3 autonomous vehicles, which are basically standard vehicles with a certain, say, add-on components, can drive on this part of the streets quite autonomously without having drivers inside. The logic behind is the so-called LDM, EDM, and GDM logic. The local dynamic map is basically the map of the car itself. So all the sensor data within the car, all the data fusion within the car results in a so-called local dynamic map, a map which updates the surrounding. And as you can imagine, a car has a line of sight depending on road conditions, weather conditions, buildings around, trees, of a couple of meters up to 200, 300 meters in very good conditions and with the latest sensoric. But you will not get, say, an icy road in 200 meters in front of you by sensor of the car, so you need this environment. And this is part also of this test drive, because we populate the so-called edge dynamic map, typical edge computing devices which collect sensor data and distribute to the cars, or even into the global dynamic map, which then helps to do traffic management, so reroute cars in case of events, events generated by cars, events generated on the street, or even events generated by the public, so emergency lanes or streets closing, construction work ahead. This goes from the traffic management into the global map and then distributes to the cars. And just to give you some ideas of what it means to build such an environment, it's just 3 kilometers of the road, and we have just 3 vehicles, a couple of traffic lights, and some parking spaces. So it sounds quite simple. As you can imagine, building this up, getting this all connected is taking a while. So a while means in this case, it's close to a year. As a side remark, there was a good amount of time negotiating with the local government and the local city and how to mount sensors on lampposts. So which height is an old lamppost, it's a new one, are we allowed to do something there? So it's quite a long undertaking and discussion, but in the end it works, and this is what we got after it. So just to make an, to stretch your brains a bit, applying the same logic for a city will obviously cost a bit. And we have a bit more road in Berlin, so from 3-4 kilometers to 5,000 kilometers, including, say, rural, urban environments where people living, shopping environments, industry environments, so complete different styles of roads to equip. And just to see also the number of vehicles in this city, and these are just the registered vehicles, there are a lot more vehicles coming in over day. The amount of data generated from this kind of environment is exponentially and needs to get managed. Obviously, we expect that in the future, we don't need to deploy every 800 meters a so-called roadside unit, which collects the data, and there are more intelligent ways to do so in the future. But nevertheless, it requires a certain amount of investment, and we expect that this kind of model of car to X or vehicle to X, vehicle to infrastructure communication, will be a kind of a standard for complex traffic situations in cities or with complex traffic situation at construction sites in order to help autonomous driving or even automated cars to get external information and deal with them. And the model behind this project is now up to, say, productizing. So what we intend to do is to generate from these initial models out of, say, research, also to build models which can be used by the OEMs to integrate into their car development, to integrate into their pattern AI development for autonomous driving patterns, in order to make sure that this knowledge of the environment goes back into car and is taken care of during driving decisions. Obviously, data volume, and I mentioned this earlier, is heavily increasing. And even when I'm saying that the number of sensors is not evenly spread in the future, we definitely expect that this kind of data volume will definitely come up in the future. So traffic, connectivity traffic between vehicles and the environment is massively increasing. We love this idea. Telecom is hopefully earning money with this idea. Nevertheless, we need to find ways to make this amount of data traffic in the future much more cost effective. So if you take current data plans from the connectivity and multiply with these kind of data volumes, you come to euros and money, which is unbelievable high and will kill any business case in the future. So it's up to us as a telecom now to take care that these kind of data can be transferred in the future with this amount of volume at the right bandwidth and the latency, but still having a business case behind. So when we're looking at the development into autonomous driving, we are still somewhere on the left-hand side. So still development mode. You might be aware that, say, all of the major OEMs do currently operate test fleets where cars are driving automated or autonomously, working closely with all of their suppliers, tier 1 suppliers, tier 2 suppliers, IT suppliers. So the amount of data generated from these test fleets ingested into big data platforms where all the machine learning starts, where all the simulation starts, where we all have these so-called SIL and HIL, software in the loop, hardware in the loop, simulations to ensure that you drive as much as possible of virtual or real kilometers in order to make sure that all your patterns work, that you do not oversee a crossing truck, that you do not oversee a pedestrian, that you do not oversee a traffic light because the sun is shining in the wrong direction. So this is all part of development and test and simulation, and exactly this is the point where this vehicle to infrastructure data are coming together and are part of the sensor data from the car and from the environment to test the patterns against and to update the patterns against. Next year, we expect the next step, so development platforms will move forward to create a kind of production readiness. So obviously, all the data generated today in the car will not transfer completely in the back end, so that's completely by far too much. So you have to find the right subset of data while you're driving to transfer, to allow data assessment, video assessment, sensor assessment while you are driving, or to pick the important pieces and retrain on a regular basis and then distribute the patterns again to all of your fleet. And this is part of production readiness. So create distributed environments, create data lakes, which are most likely located all over the world. You cannot transfer this amount of data on a regular basis. And obviously this requires a governance. So who owns the data? Who can deal with the data? Who makes sure that the privacy is still taken care of? So in the end, this is about production readiness, and this will take at least a year, more likely 2 years, and then combining with the legal requirements to get a certain model approved. It's the homologation process, the certification process, which might be easier in the European Union because you have one legislation, one rule set, but in the end, a car manufacturer needs to get this certified all over the world in the same way, and to prove the millions of kilometers done with such an autonomous driving car in the different environments, cities, motorways, rural environments. That's the key part of this certification, and then preparing the global rollout in order to have, say, operations platforms. And basically, at the right-hand side, we are then back into the monetization of data. And when we talk 2020 plus, this is obviously not, say, full fleet, everything autonomous. This might take another 10 years. But for the first kind of automated driving, not yet autonomous, automated driving, we will see this in 2020 plus on an operational way. So in the end, what we're talking about here, it's a lot of technology. It's a lot of technology we are combining together to make it work, but still having legal governance impact, having this ecosystem of people coming together. And in my personal opinion, this is quite a major development in the next years, and we are all part of it. So yes, it's technology, but in the end, it's magic. So with this, thank you, and enjoy the rest of the day.